Introduction to compound interest. So what is compound interest? Compound interest is the interest that calculates on the both original amount, principal, and the interest that has been added over time. This is different from simple interest, which is only based on the principal. When we borrow money or invest our saving, compound interest affect how much we will pay or earn. For example, when we keep money in the bank, interest is added to our account every year. The next year, the bank calculates interest again based on the new total, including the previous earned interest. If we observe our bank statement, we will notice that the amount of interest increases each year, even though the principal remains the same. This shows the bank normally use compound interest, not simple interest. Compound interest help our money grow faster when we save or invest, but it also causes the amount we must repay on the loan to increase. Therefore, understanding how compound interest works is important for making smart financial decisions. The logic of compound interest. The future value, denoted as S, is calculated using the formula S equal P times 1 plus I power N, where P is the original principal and N is the number of interest period. The compound interest, represented by I, is calculated using I equal S minus P, which show the total interest earned over time. To find the present value, we rearrange the formula as P equal S divided by 1 plus I power N. The periodic interest rate I is obtained by dividing the nominal interest rate K by the number of compounding period per year, M, where I equals K over M. The total number of the period is calculated as N equal M times T, where T is the times in years. The value of M depends on the compounding frequency, such as annually, monthly, weekly, daily. Case study 1. Hakim plans to buy a house in a few years. To achieve his goal, he decides to deposit part of his income into an investment account that offers 4.1 annual interest, compounded quarterly. After 8 years, his savings has grown to 180,547.26. After reviewing his financial progress, Hakim begins to explore other options for reaching his housing goal sooner. So question A, how many money did Hakim initially invest at the beginning? Okay, for part A, we need to find the original amount deposit, which is principal. We are given that the final amount after 8 years is 180,547 ringgit 26 cents. The interest rate is 4.1% per year, and it is compounded quarterly. Since quarterly means 4 times a year, we divide the annual interest rate by 4. This is the interest rate for each quarter. Next, we find the number of compounding period. 8 years multiplied by 4 quarters per year equals 32. So there are 32 compounding period. Now, we use the compound interest formula. S equal P times bracket 1 plus I close bracket power N. We substitute the value. 180,547 ringgit 26 cents equal P times 0.041 divided by 4 to the power of 32. When we calculate 0.041 divided by 4 to the power of 32, we approximately 1.385873185. To find the principal, we divide the final amount by this value. So 180,547 ringgit 26 cents divided by 1.385873185 equal to RM 130,276 ringgit 90 cents. This is the principal or the original amount deposit.
Okay, now for part B, calculate the total interest earned over the 8 years. The formula is interest equal final amount minus principal. So we take 180,547 ringgit and 26 cents and subtract 103,276 ringgit and 90 cents. This gives 50,270 ringgit and 36 cents. So the total interest earned over 8 years is 50,270 ringgit and 36 cents. Okay, for part C, if Hakim wish to have RM250000 in the same account, how long will it take at the same interest rate and compounding frequency? We are still using the compound interest formula, which is S equal P times bracket 1 plus I close bracket power N. Here, S is 250,000 ringgit and P is 130,276 ringgit and 90 cents. The annual interest rate is 4%, and it is compounded quarterly. So we divide 0.041 by 4, so it gives us 0.01025 close bracket power N. Next, we substitute the value into the formula. 250,000 equal 130,276 ringgit 90 cents times bracket 1.01025 close bracket power N. Then we divide both sides by the principal. So we get bracket 1.01025 close bracket power N equal 250,000 divided by 130,276 ringgit 90 cents. This gives us approximately 1.918989475. Now we need to find N, the number of compounding period. To do that, we use logarithm. So N equals log of 1.918989475 divided by log of 1.01025. When we calculate this, we get approximately 63.9155 periods. Because the interest is compounded quarterly, we must convert this into years. So we divide 63.9155 by 4. This gives us about 15.9789 years. So the time need to reach 250,000 ringgit is approximately 16 years.
But we need to find the interest rate required to reach 300,000 in 5 years. We use the compound interest formula, which is S equal P bracket 1 plus I bracket power N. Here S is 300,000 and P is 130,276.90. Next, we find the number of compounding periods. Since the interest is compounded quarterly, we multiply the number of years by 4. So 5 years times 4 equals 20. This means N equals 20 periods. Now we substitute the now values into the formula. 300,000 equal 130,276 ringgit 90 cents times bracket 1 plus I close bracket to the power of 20. Next, we divide both sides by the principal. So 300,000 divided by 130,276 ringgit 90 cents equals bracket 1 plus I close bracket power 20. This gives approximately 2.3028. Now, to remove the power of 20, we take the 20th root of 2.3028. So 1 plus I equals 2.3028 to the power of 1 over 20. And this gives us 1.0426. Finally, we subtract
1 from both sides to find the interest rate. So I equals 0.0426. This means the interest rate needed to reach 300,000 in 5 years, compounded quarterly, is approximately 4.26% per year. Okay, now we have to find K. K equals to 4 multiply 0.0426. So we get 0.170.
Introduction to annuity. So what is annuity? An annuity is a financial arrangement where equal payments are made at regular time interval, such as shop rental, insurance payment, or loan installment. The same amount of money is paid or deposited repeatedly over a certain period. Annuity calculations are often used by financial consultants to help people to plan investment and by property agents to estimate loan repayment. The term of an annuity is the total duration from the first to the last payment, where the payment interval is the time between each payment. For example, if a car loan requires equal monthly payment for 4 years, then the term of the loan is 4 years and the payment interval is monthly. For this methodology, we use annuity formulas to calculate the value of periodic payment over a certain period of time. First, the future value is an annuity, denoted as S, is calculated using the formula S equal R times open bracket 1 plus I power n minus 1 close bracket divided by I. This formula is used to find the total accumulated amount at the end of the investment or loan period. Net, the present value of an annuity, represented by A, is calculated using A equal R times open bracket 1 minus 1 plus I power negative and close bracket divided by I. This formula helps us determine the initial value or amount before making periodic payment. To find interest earned or charged, we use two formulas. For future value, interest is calculated as I equal S minus NR, while the present value, interest is calculated as I equal NR minus A. In this formula, R represents the periodic payment, I is the periodic interest rate, and N is the term of the loan and investment.
Which paid 6% compounded monthly. Find the amount in his daughter's account at ABC Bank after 2 years. Okay, for Ahmad questions, we want to find the total amount he will have after saving regularly for 5 years. Ahmad deposits 500 ringgit every quarter, which means 4 times a year. The interest rate is 4% per year, and because it is compounded quarterly, we divide it by 4. Next, we find the number of compounding periods. 5 years multiplied by 4 quarters per year give us 20 compounding periods. To find the value of the annuity, we use the formula S equal R times bracket open 1 plus I bracket close to the power of n minus 1, all divided by I. We substitute the values. R equals 500, I equals 0.04 divided by 4, and n equals 20. So we calculate bracket 1 plus 0.04 divided by 4 to the power of 20 minus 1 divided by 0.04 divided by 4. This gives us about 22.01900399. Now, we multiply this value by 500. So, the total amount Ahmad will have after 5 years is Rm 11,009 ringgit and 50 cents. Ahmad then withdraw half of this money. When we divide 11,009 ringgit and 50 cents by 2, we get 5,504 ringgit and 75 cents. After Ahmad withdraw half of his saving, he still have Rm 5,504 ringgit and 75 cents left in his account. Now, this remaining amount earns interest at 6% per year and the interest is compounded monthly. So, we first divide 0.06 by 12 because there are 12 months in a year. Next, we calculate the number of compounding periods. Since the money stays in the account for 2 years and the interest is compounded monthly, we multiply 2 years by 12. This gives us 24 months. Now, we use the compound interest formula, which is S equal P multiplied by bracket 1 plus I close bracket power n. We substitute the value. P equal 5,504 ringgit 75 cents. I equals 0.06 by 12 and n equals 24. So, we calculate 5,504 ringgit 75 cents times bracket 1.005 to the power of 24. When we compute this, we get approximately Rm 6,204 ringgit and 73 cents.
For part B1, we need to find the number of monthly payments, which is N. We are given that the total loan amount is 80,000. The monthly payment is 1,779 and 56 cents, and the interest rate is 12% per year compounded monthly. Since the payment is monthly, we divide the annual interest rate by 12. So, the monthly interest rate is 0.12 divided by 12. Next, we use the present value of annuity formula. A equals R times bracket 1 minus open bracket 1 plus I close bracket power negative n divided by I. Now we substitute the values. 80,000 equals 1,779 ringgit 56 cents times bracket 1 minus open bracket 1 plus 0.12 divided by 12 close bracket power negative n divided 0.12 divided by 12. Next, we rearrange the equation to isolate the exponential term. After simplifying, we get 1 minus open bracket 1.01 close bracket power negative n equals 0.5505. Then, we move the 1 to the other side. So, 1 minus open bracket 1.01 close bracket power negative n equals 0.449549326. To remove the power of negative n, we take logarithm on both sides. So, log of open bracket 1.01 close bracket power negative n equals log of 0.5505. Using the logarithm rule, negative n times log 1.01 equals log 0.5505. Now, we divide both sides by log 1.01, so n equals 60. Therefore, the number of monthly payments is 60 months, which is equal to 5 years. Now, for part B2, we need to find the total amount accumulated. We use the future value of annuity formula. S equals R times bracket, open bracket 1 plus I close bracket power n minus 1 divided by I. We substitute the values. S equals 1,779 ringgit 56 cents, time bracket open bracket 1 plus 0.12 divided by 12 close bracket power 7 minus 1 divided by 0.12 divided by 12. When we calculate, times bracket open bracket 1 plus 0.12 divided by 12 close bracket power 7 minus 1 divided by 0.12 divided by 12, we get approximately 7.21353521. Finally, we multiply 1,779 ringgit 56 cents by 7.21353511. So the total amount accumulated is 12,836 and 92 cents. First, we use the annuity formula. A equals R times open bracket 1 minus open bracket 1 plus I close bracket power negative n close bracket divided by I. A equals R times open bracket 1 minus open bracket 1 plus I close bracket power negative and close bracket divided by I. Next, we substitute the given values into the formula. A equals 1,779 ringgit 56 cents times open bracket 1 minus open bracket 1 plus 0.010 close bracket power negative 20 close bracket divided by 0.01. After calculating the expression, we get the final answer. Therefore, A is equal to RM 8,213 ringgit and 14 cents.